1 minute ago, a family in southern Michigan was sitting down to a quiet Friday afternoon. The air outside was unseasonably warm, the sky bruised and restless. A wall of rotating wind, darker than charcoal, dropped from the clouds and began devouring everything in its path. Homes lifted off their foundations like paper, roofs peeled away in seconds. Why did a tornado with near EF4 wind speeds strike Michigan in early March, a time and place where storms like this almost never happen? How did a storm rated only a marginal risk become a killer in under 30 minutes? And if the atmosphere is shifting its worst fury into places that have never prepared for it, what happens next? The footage is the kind that makes your chest tighten. Entire houses shredded apart in real time, their walls folding inward like crumpled aluminum, debris spiraling hundreds of feet into a blackened sky. This was not supposed to happen here, not like this. But it did. On March 6, 2026, a powerful tornado tore through southwestern Michigan as part of a severe weather outbreak rolling across the central United States. The system stretched from Kansas and Oklahoma through Texas and into the Great Lakes. At least 4 people lost their lives. More than 20 were injured. 3 of the dead were in the Union Lake area near Union City in Branch County. A 4th victim, a 12-year-old boy named Silas Anderson, died in Cass County near Edwardsburg after a tornado struck, and his parents, unable to find him in the aftermath, called 911. The scale of destruction shocked even seasoned emergency workers. This was one of the most devastating tornado events Michigan had experienced in decades, arriving in early March, a time when tornadoes in this part of the country are vanishingly rare. And the destruction was only beginning to reveal itself. Union City, Three Rivers, Edwardsburg, the communities that bore the worst of the impact read like a casualty list. The destruction spanned Branch County, Cass County, and St. Joseph County. Homes were flattened to their concrete slabs. Roofs were ripped clean off buildings and hurled blocks away. Century-old trees lay uprooted across roads, their root systems pointing toward the sky. Power lines draped over crushed vehicles like dead vines. In Three Rivers, the tornado carved directly through a commercial strip along US 131. The front of a Menards home improvement store was torn apart, its skylights shattered inward. Cars in the parking lot were lifted and scattered across curbs and grass, their windows shattered. A nearby Dollar Tree was gutted entirely. What made it worse was the speed. The entire wave of devastation at that store lasted roughly 30 seconds. Residents across the region had been filming the sky, some from decks, some from windows. Their footage shows the funnel thickening and descending, moving with terrifying speed. Meteorologists would later warn that recording a tornado from your home is extremely dangerous. The paths of these storms are violently unpredictable. But no one expected to need that warning. Not in Michigan. Not in March. The National Weather Service confirmed the tornado near Union City as an EF3 on the enhanced Fujita scale. Preliminary surveys estimated peak winds of at least 150 miles per hour. But as assessments continued, NOAA damage indicators pointed to winds as high as 165 miles per hour, just 1 mile per hour shy of an EF4 classification. The final rating remained open to revision. An EF3 tornado is classified as causing severe damage. At this intensity, entire stories of well-constructed homes can be destroyed and heavy vehicles thrown like debris. The Weather Network reported that this was the earliest violent tornado on record in a Michigan calendar year since at least 1950. Based on available data, no EF3 or stronger tornado had previously been confirmed this early in the year in the state's modern records. Based on available records, no March tornado in Michigan had reached EF3 intensity since the 2012 Dexter tornado 14 years earlier. What the NOAA Damage Toolkit's 165 mile/hour reading could imply is that the final rating may yet be revised upward.
But the wind speed was not the only thing that stunned researchers. To understand what created this monster, you have to look at what the atmosphere was doing in the hours before touchdown. A warm front surged rapidly northward into the Great Lakes region, dragging with it a river of warm, moisture-laden air from the south. That warm air collided with a mass of cold, dry Canadian air already parked over the upper Midwest. The collision generated extreme atmospheric instability. According to the NWS, surface-based CAPE values ranged between 500 and 2,000 joules per kilogram along the storm's path. That is a measure of the energy available to fuel violent updrafts. Wind shear between 40 and 50 knots helped the developing storm rotate. Helicity values of 200 to 250 meters squared per second indicated an atmosphere primed for tornado genesis. A lone supercell thunderstorm developed over LaPorte County, Indiana, and tracked northeast into Michigan. It intensified rapidly as it crossed the state line. The atmosphere had become a loaded weapon. No one saw the trigger being pulled. Within hours of the tornado's passage, Michigan Governor Gretchen Whitmer activated the State Emergency Operations Center. The activation was set at Level 3 monitoring status. Emergency crews fanned out across Branch, Cass, and St. Joseph counties. Their mission was grim: search for missing persons, clear blocked roads, and restore power to thousands left in the dark. Recovery operations continued through the night. Roads remained impassable and entire neighborhoods were unrecognizable. The smell of wet insulation, splintered wood, and exposed earth hung in the air. For the families who survived, the silence after the storm was almost worse than the noise. What no one could quite explain was why it happened at all. The Storm Prediction Center had issued only a marginal risk for severe weather across southern Michigan on March 6th. That designation, a level 1 out of 5, typically signals a low chance of isolated thunderstorms, not violent tornadoes.
The forecast models had not anticipated a storm of this magnitude. The ingredients were present, but they assembled faster and more intensely than any model projected. According to NWS analysis, both the significant tornado parameter and the violent tornado parameter were maximized over far southern Michigan between 3 and 4 p.m. That was precisely when the tornado struck. This kind of rapid intensification is one of the hardest phenomena in meteorology to predict. The storm went from marginal threat to deadly EF3 in less than an hour. It was a failure not of negligence, but of nature outpacing technology. And this was not an isolated event. The Michigan tornadoes were part of a broader severe weather outbreak that swept the central United States between March 5th and March 7th. The same system also spawned destructive storms in Oklahoma, Kansas, and Texas. In Oklahoma, 2 people were killed near Beggs, south of Tulsa. In Major County, an EF2 tornado west of Fairview struck a vehicle on US 60, killing a 47-year-old mother and her 13-year-old daughter. The National Weather Service identified 7 preliminary tornado tracks across eastern Oklahoma alone. In southern Kansas, 2 EF1 tornadoes were confirmed near Bluff City on the night of March 5th, and an EF0 later struck the Kansas City area late on March 6th. Across all affected regions, the total death toll reached at least 8. More than 100,000 people lost power. The scope of the outbreak was staggering, but for some scientists, the most alarming detail was not how many tornadoes formed, but where. The pattern was shifting beneath everyone's feet. For decades, the geographic heart of American tornado activity has been Tornado Alley, centered on the Great Plains states of Texas, Oklahoma, Kansas, and Nebraska. But researchers have been tracking a slow, steady migration of that activity eastward. A landmark study co-authored by Naresh Devaneni at the City University of New York found that large tornado outbreaks shifted 400 to 500 miles east between the late 1980s and 2019. The new concentration falls across western Tennessee, Kentucky, northern Mississippi, Alabama, and increasingly the Midwest. According to Scientific American, these outbreaks are clustering in tighter geographic areas. They may be growing fiercer and more frequent. Michigan is not traditionally tornado country. The The state averages roughly 17 tornadoes per year, mostly in its extreme southern counties. But based on what we know, the March 2026 event fits a larger pattern that researchers say is accelerating. The question is no longer whether the pattern is shifting, but how fast and how far. Several converging atmospheric factors appear to be driving this migration. Warm, moist air from the Gulf of Mexico is now traveling farther north than it did in previous decades, penetrating the Midwest and Great Lakes region more easily. Simultaneously, cold air masses descending from Canada are colliding with this warm, humid flow at higher latitudes. The result is the kind of atmospheric instability that breeds supercell storms. The boundary between dry western air and moist eastern air, known as the dry line, has shifted roughly 140 miles eastward since the late 1800s. This could imply that warming temperatures are extending severe weather seasons earlier into the year, something the March 6th event appears to support. But not all researchers agree on the degree to which climate change is driving the shift. Others argue that improved radar detection and denser population in the southeast may inflate the apparent increase. The debate remains active. The uncertainty is itself a source of concern. No one can say with certainty where the next violent tornado will appear. The most extreme tornadoes on record are classified EF5, with wind speeds exceeding 200 miles per hour. These storms can obliterate homes from their foundations and gouge scars into the earth itself. They are mercifully rare, representing less than 1% of all tornadoes. Before the Enderlin, North Dakota EF5 in June 2025, the United States had gone 12 years without one, dating back to the 2013 Moore, Oklahoma tornado. But even an EF3 is classified as severely destructive. It sits at the threshold where survival inside a home becomes a matter of luck, not preparation. According to FEMA, EF3 and stronger tornadoes account for roughly 6% of annual U.S. tornadoes. Yet since 1980, they have caused more than 75% of all tornado-related deaths. The reason is simple and terrifying. Most American homes cannot survive them. But the buildings themselves were part of the problem. The vast majority of residential construction in the United States relies on wood frame structures with drywall interiors. These homes are affordable and quick to build, but devastatingly vulnerable to high winds. In an EF3 tornado, entire floors are destroyed. The walls, once the roof is gone, lose their structural support and collapse inward. If the frame is not bolted to the foundation, the house may slide off its slab entirely. FEMA research has shown that reinforced concrete structures and dome-shaped designs fare significantly better. Dome buildings are particularly resilient because their rounded shape lets wind flow around them. Flat-walled wood homes absorb the full force of the vortex. Across the hardest-hit neighborhoods in Union City and Three Rivers, the homes were almost entirely wood-framed. They never stood a chance. The problem is compounded in regions like Michigan, where tornado shelters and safe rooms are far less common than in Oklahoma or Kansas. Many residents had no basement, no reinforced room, and no time. In many parts of Europe, homes are built with heavier materials, such as concrete and brick. Tornadoes there tend to cause roof damage rather than total structural collapse. In contrast, an American wood frame home struck by an EF3 can be reduced to a bare slab in under a minute. NWS surveys showed homes along Union Lake swept completely off their foundations. The cheaper construction lowers building costs. It also raises the body count.
There was one moment amid all the data and devastation that cut through everything. James Taylor, 63 years old, was home in Union City when the tornado warning hit his phone. He grabbed his 2 dogs and ran for the basement. "I made it right to that window right there with the 2 dogs," he later said, his voice steady but hollow. Outside, the air screamed. Debris hammered the walls like fists. The sky, as often happens during violent tornadoes, seemed to shift to an unnatural green before everything went black. Witnesses across Union City would later describe a grinding roar, like a freight train being dragged across gravel. It filled every corner of the house. When it stopped, the neighborhood was gone. Trees lay across roads like fallen soldiers, and the smell of torn earth filled every breath. He was alive, others were not. Between March 5th and March 7th, 2026, multiple tornadoes carved their way across the United States in one of the most destructive early-season outbreaks in recent memory. At least 8 people were killed across several states. Communities in Michigan, Oklahoma, Kansas, and Texas suffered major structural damage, widespread power outages, and catastrophic loss. The scars will take years to heal. The debris fields stretched for miles. Insulation clung to barbed wire fences. Personal belongings lay scattered across fields where homes once stood. In Union City, residents wandered through wreckage that bore no resemblance to the neighborhoods they had known that morning. Based on what we can assume from the data, tornado activity appears to be migrating into regions historically considered low risk. Early season events like the March 6th disaster seem to be arriving earlier and intensifying faster than in previous decades. Scientists know that the forecasting tools available today were not enough to prevent this disaster. What they do not know is whether this is an anomaly or the beginning of a new pattern. Whether the quiet months in Michigan will ever truly be quiet again. Whether the next marginal forecast will once again conceal a monster. The ground beneath the American Midwest is not shifting, but the sky above it is. And if the atmosphere keeps changing faster than our ability to predict it, the question is no longer whether another storm like this will come, it is whether anyone will see it in time.